Hello everybody. Last time we started, actually we continued our discussion on
Sorry, we cannot see your screen.
Okay, so good morning everybody. Last time we started, actually we continued our discussion on the inheritance, and we talked about the special functions that are not directly inherited. They are available to us, but actually they are not directly our functions if we are deriving from them. And these functions are copy constructor, assignment operator, and destructor. Since these are related to big three and dynamic memory allocation, we need to be careful about them. We talked about them. We talked about how we use the destructors, and we talked about the destructor calling order. We usually say that the destructor calling order is just the opposite of the constructors. It seems that way, and I think I have shown you this example. Okay, that was what we did last time. So let's continue, and let's finish up with this chapter 14, and we are gonna start another topic which is related to inheritance. We are gonna look at the final fundamental topic of the object-oriented programming, polymorphism. Okay, do we have any questions from last lecture?
We cannot see the slides.
Böyle çıkarma.
Do you hear me?
Dersi dinleyin. Yok, tamam.
Okay, do you have any questions? Okay, if there are no questions, again, my Teams is broken. I cannot read your chat questions. So if you have any questions, just use your microphone. Okay, so destructor calling order, we just talked about it. If B derives from A and A derives from B, then the destructor of class C is called first, then B, then A. That makes sense. Why? Because it looks like this, right? I mean, if we think in terms of memory, okay, let's say this, okay? This is our class A, B derives from A, and C derives from B. It's like this. How does a class C object look like? Okay, a class C object is going to have a class B object in it, and B object is going to have a class A object in it. Okay, so it makes sense to call the destructor of the class C first so that it can take care of this area, right? Then the class B destructor will be called, and it will take care of this area. And finally, we will call the destructor of A, which will take care of this area. Okay, if I destruct the class A object first, then class C object will be in a bad situation. It will be a disabled class object. Why? Because it is missing some part of it. But if we start from the other end, from C, then B, then A, that's the right order. So, and we cannot change this. Because remember when we write the destructors, we don't call other destructors. Okay, so We don't call other classes destructors. Okay, question for you. When we write a copy constructor, we call the base classes constructor, right? Why don't we do the same thing? When we write a destructor, we don't call the base classes destructor, but the destructor is called automatically. In C++, designers didn't let us do this. I mean, we don't and we can't actually call the base classes destructor in our derived class destructor. But in copy constructor or any type of constructor, they tell us that you should call the base classes constructor. Why is this so?
Hocam, can you repeat, please?
Question is this. I always kept telling you that if you are writing a derived class constructor, it is either copy constructor or regular constructor. I told you that you should call the base classes constructor, right? I always ask this. I always ask you to do this. But we are saying that you cannot and you should not call the base classes destructor when you are writing the derived class destructor. Okay? You don't call the base classes. See here? Here's an example. That's what we did, right? This is class base constructor and destructor. This is class derived. The derived constructor calls the base classes constructor, but derived destructor doesn't call the base classes destructor, and you cannot actually. And I'm simply asking, why is this so? I mean, constructors and destructors are similar. When it comes to derived class constructors, you need to call the base classes constructor. But when it comes to derived class destructors, this is not the same. We say that you cannot call the base classes destructor and you should not call the base classes destructor. See, I am not calling anything in the base class about the destructors. Calling order is automatic.
Maybe double free error.
Say that again, Merve.
Double free error. Compiler error.
Yeah, but of course, when you call, it's going to be a compiler error, that's right, but I am asking you, why made that decision? Why made this a compiler error? Why this is not a compiler error for the constructor, but it's a compiler error for the destructor? That's my question is.
Because there is only one type of destructor. If we would call it explicitly, it would be irrelevant. There is no need to call explicitly destructor. Compiler already knows what to call.
Exactly, because there is no overloading of the destructors. Why? Because destructors, they don't take any parameters. You cannot overload them. There is only a single destructor. So if I call the destructor, what am I going to call? The single destructor, and compiler is doing automatically. But with the constructor, there are many forms of constructor. There are copy constructors, overloads of the other constructors, etc. And there are parameters to pass, okay? So that's why they made that decision. For the destructors, you don't call the base classes destructor in the derived class destructor, but for the constructor, it is just the opposite. You should call it, okay? You should call it. Don't let the compiler call the base classes constructor for you. Okay, good. Okay, now an important topic, very important topic actually, and we did this actually, but we didn't give proper names to this topic. ISA versus HASA relationship. We covered both. You know both of them, but we didn't get the names yet. ISA relationship between two classes is inheritance. Okay, I think at the beginning of this chapter I drew that nice picture. Well, it is nice for me. I don't know about you. So there is a relationship between the employee class and the salaried employee. Okay, again, there is a relationship between employee class and hourly employee, but there is has a relationship between employee and day of year class. So composition is another name for has a relationship, and inheritance is another name for is a relationship. And they seem on the memory, they seem okay, they seem very similar, but in philosophy, in object-oriented philosophy, they are very, very different. They are very, very different. Why are they different? Because, okay, when we say different, of course, there are similarities. There are similarities, but we like to think them as very different concepts. Okay, inheritance is a relationship. Okay, and the compiler knows about this. Compiler knows that if I have this employee and hourly employee relationship, if there is a relationship between these two classes, if my function void f takes a employee object, okay, if this is my function, in my main function, okay, let's say I have employee E and hourly employee HE, I can call this function with this object and I can call this function with this object, no problem. Okay, so these are all both fine. Why? Because the compiler knows that each of the hourly employee class objects are objects of this employee class. There is a relationship between them. Okay, and the compiler knows about this. Okay, compiler knows that's why we are very careful. Has a relationship is composition, exactly. Okay, a class contains objects of another class as its member has a relationship. Remember in our example, for example, in your homework, okay, in your homework, for the last 2 or 3 homeworks, you have this hex class, right? And you have this cell class. And there is has a relationship between these, and we show this relationship with this diamond shape, with a diamond shape, okay? There is has a relationship between these two. Or previously, I think we did was, yeah, that is this holiday class. Remember the holiday class? And there was this day of year class. And I think, yeah, we did it that way. There is a composition between these, right? Again, there is has a relationship between these. Both of them are very good examples of code reuse. Okay, both of them are good for code reuse, but they are very different ways of using code reuse. Okay, why? Because once I have this day of year class, I could use this day of year in a person class or a holiday class or anywhere I like. Okay, once I have this, I can use it anywhere I like. So it's a code reuse, and I don't have to think about the day of year class anymore when I write the holiday class. Okay, so there is a nice example of has a relationship. So when you are thinking, people are usually confused when they start doing the inheritance first. Okay, when they start doing inheritance first, for example, some people do this. Some people do this. Day of year. Do you guys remember the? Do you guys remember the? Okay. Do you guys remember the elements of the day of year? I think it was I'm going to just say get day, I guess, right? Get day and get month, something like that. And if I do such a crazy thing, and if I derive a holiday class from this, and I think parking enforced is the function for this. Okay, if I do this, if I derive my holiday class from day of year class, let's say, let's make a holiday age. When I say cout age dot get day, it will print something on the screen. When I say cout, okay, age dot parking enforced, it will print true or false on the screen, right? It seems like it works, right? It seems like it works because for each holiday there is a day field and there is a month field, okay, and for each holiday there is a parking enforced thing, but the logic is wrong. I mean, it may seem at the beginning it is kind of correct, but it is not correct because holiday is not a day of year, okay? It has a day of year property, but it is not a day of year. There is no is a relationship. I mean, some people are confused about this, and you should always think about, you should always think about can I treat a holiday object like a day of year object? If the answer is yes, then there is a relationship, okay? But there is no is a relationship between these, so this hierarchy is wrong. Although these look like they are working. We are getting what we want, okay? At the beginning it might seem okay, but later you are gonna realize that this is not going anywhere if you're gonna have a large hierarchy. Okay, good. Any questions about is-a and has-a relationships? Okay, I guess there are no questions. Then we will continue if there are no questions. The first question, when I first introduced, for some reason, okay, let me copy this. Let me copy this. Okay, and put it in here. Good. The first question, when I introduce the inheritance, especially the inheritance notation in C++, people always ask about this. What happens if I write public in private here instead of public? What happens if I write protected in there? And my answer would be, just wait, you're gonna see, and we are not going to do that. Okay, so you could write private or protected in that position, but we never do that, okay? Okay, protected and private inheritance is possible in C++, but I have never used it. I did not see anybody using it, but they are there, okay? If you are doing a protected inheritance, okay, if you are doing protected inheritance, you are gonna say salary the employee is an employee, actually it's a protected inheritance. And when you do that, okay, public members in the base class become protected in the derived class. So all the publics of the base class become protected. When you do the private, okay, all the members in the base class, doesn't matter public, protected, or private, they will be the private members of the derived class. And these two are not is relationships. Okay, what did we say? Inheritance is a relationship. Well, I mean, if these are not protected and private, these are not protected inheritance and public inheritance. If they are not is a relationship, they are not inheritance, then we are not interested in them. Okay, we are not interested in them. Why do you okay, question, why do we say that protected inheritance is a relationship? That's what I said, right? Protected or private inheritance, if you write protected here, private here, then this is not a relationship anymore. Why do I say that?
Access levels are different.
Access levels are different. What do you mean? Is a relationship needs? Do you say is a relationship needs access levels? So explain your answer a little bit.
We cannot use the same members.
Exactly, we cannot use. Remember what I said before? Here, what does this function do? Okay, this function is going to call, it will say cout e.getName, right? Because if this is an employee, if E is an employee, I can call the functions of the employee class, right? That's what I would do. But if I do the protected or private inheritance, I cannot call this getName because getName becomes private or protected, right? So if I cannot call it, then I cannot say that there is a relationship between this function, this employee E and hourly employee HE. That's why we say that these are not relationships, and we are not interested in them. Okay, the moral of the whole story of this slide is protected and private inheritance is possible, and we will never use them. Okay, I put this slide just because people are very curious about it. They keep asking me about this question, and the answer is, well, it is possible, but we don't use them. Okay, good. But it gives me a good position to explain the ISA relationship. Okay, why do we call it an ISA? Because again, ISA relationship is known by the compiler. Compiler knows. Then we are gonna use this a lot. We are gonna use this a lot. In fact, you have been using this a lot. You have been using this a lot. And you're gonna see where we have been using them later in a few lectures. Okay. Okay, so let's continue. Multiple inheritance in C++ is possible. Okay, multiple inheritance is possible, and sometimes we need it. For example, let's say I have a person class and I have a employee class. In the person class, each person, I know that each person has name, each person has social security number, and each person has address. I know these. Each employee has salary, and each employee has start date, right? Start date. So get to the answer for everything. Okay, I know these. And in fact, when I make this, hourly employee class. I know that hourly employee is both an employee and a person. And I can say that, okay, I am going to do multiple inheritance. I am going to do multiple inheritance. How am I going to do that? This is how you're going to do that. If I have a class named derived multi, and I'm going to derive it from two classes, base 1 and base 2. Okay, base 1 and base 2. And these two classes will be my base class, both of them. And there is a relationship between these two and between these two. So hourly employee is both a person. Hourly employee is again an employee. Okay, so we need to be careful a little bit about this. The book says this. It is dangerous. Some say it should never be used, and etc. I don't agree with this. I don't agree with this. Okay, I don't agree with this because multiple inheritance is useful and it is used in many places. As long as you are careful about the problems of it, you should be fine. Where does the problem come from? Problem comes from usually this. Okay, let's say I have a class. Let's say, let me try to give you a good example, a real world example. Okay, let's do the person thing again. Let's say person, and person has a name in it, right? A name, which is a string. And I will derive a student, and I will derive an employee. Okay, so student has in it, for example, GPA is a double, and employee has okay, and employee has in it salary, right? It's a double too. Let's say I like to make a new class, student employee. It makes sense to derive this class from both employee and student, so that student employee has the GPA, and it has the salary too. But the problem is this: student employee is a person too. Okay, it's a person too. So there is one inheritance path in here, another inheritance path in there. So this name string name is going to be inherited twice. Not once, but 2 times. If I inherit this person 2 times, then that's going to be a problem, because in my objects of this class, let's try to draw the memory diagram again. Memory diagram. If I have a student employee, inside the student employee, there should be a student, but inside the student there is a person, right? Person. Also in the student employee, there is this employee again, and another person in there. And inside the person, what do I have? I have name and another name. See, I am inheriting the same thing twice, and it is making my object complicated, and it is wasting memory and etc. Okay, so C++ has some solutions for these kind of problems, but we will not go into those. Usually, at the beginning level, people don't try to teach that kind of stuff to the beginners, and they just say that a multiple inheritance is possible, and be careful about it with C++. In Java, there is no multiple inheritance. Okay, there is no multiple inheritance in Java, but they found a solution with some other mechanism that behaves like a multiple inheritance, but in fact it's not multiple inheritance. So it is kind of sub-inheritance mechanism, and we will see when we learn about Java. Okay, good. Any questions? Any questions about multiple inheritance, or is a relationship, or it has a relationship? As we decided last week, our midterm exam will be on Wednesday morning during the class time. It will be a 2-hour exam. The instructions for the exam, we either posted it or we are going to post it in a few minutes. So read the instructions very carefully today, and if you have any questions about the instructions, ask me tomorrow. Okay, are there any questions about the inheritance? The whole inheritance chapter? I think that's it for the inheritance chapter. No, well, maybe I should. We never did any examples about inheritance that uses dynamic memory. Let's go to the book slides. I am not going to do the employee, but we are going to do what? Where are my? Okay, let me open this source code from the book, chapter 14. Yeah, I am going to open this up. Okay, remember our PF array, partially filled array, double. This is my header file for that one. And see, this is protected. It's not private, but protected. As an exercise, make this private and change the code accordingly. I'm going to ask you that. Okay, since this class includes a pointer and assignment of this pointer, and the copy constructor handling of this pointer will be problematic. That's why I need the big three: assignment operator, destructor, and the copy constructor here. Two constructors, you all remember this. Add element, okay, is not a const function because it is going to modify the class. These are all const. Empty array is not a const, and I have my index operator and everything. Okay, good. So I know this one. So this is what I'm gonna do. I am gonna write another class that will be very similar to PF array D. That will be very similar to PF array D, but it will do something more. It is going to be a specialized version of it. It is going to do this. I am going to say, okay, let me try to hide the private. Okay, good. So okay, so PF array D backup, okay, is a PF array D class actually, but on top of it, it says that it can take the backup of the object. What do I mean by backup of the object? It saves the whole array to some place, okay, at some position, and when I need it, I can restore it. Okay, I can restore it. If I want to draw it, it's something like this. Let's say this is my memory, PF array pf array d pf, let's say 10. So in this one I have pf, it has 3 fields, right? It has 3 fields. It is capacity is 10. There are 0 elements in it, and my A is pointing to some place in the memory, and there are 10 elements in it, right? If I do pf dot add element, let's say 72, so 72 will be added here, the use will be 1, etc. So this is what I'm going to do. Let's say this is not pf_array_d, but this is pf_array_d backup. When I say this, it's going to take a backup of this object. For example, it will do this. It will copy everything from this position to this position, 72 and everything. Okay. And of course, I will have to save these two too. Okay. I took a backup. When I do the restore, I will copy them back to the original position. Okay. So I am taking a backup and I am restoring it. I am restoring my backup. So this pf_array_d backup behaves exactly like a pf_array_d. It has all the functions like add element, full, get capacity, get number used, get empty array. Okay. On top of it, I will have backup and restore. Okay. So how would I do this? In my private section? Now this is private, this is not protected. Okay. So it says that I am going to do this. I am going to have a double pointer and I am going to have a use B, backup B. So B means backup. Okay. So it looks like my objects are going to be like this. So it's going to be let me okay. I am deleting everything and I will write this in a more readable way. I am not arguing that it will be readable, but this will be more readable. pf array d backup pfb10. When I say this, I think in the memory this pfb is going to be like, okay, there is this other part where I have this pf array, and pf array has 3 things in it, right? It is going to have used, capacity, and a double pointer, right? So my used is going to be 0, capacity will be 10, and this is going to point to some place in memory, and that memory will have 10 elements in it. On top of it, in this pfb object, there will be 2 other places. One is going to be, what was the name of the use B. Okay, used B, and another double pointer, and this double pointer is going to point some other place in memory, and this is going to be used for backup space. Okay, again there will be 10 elements in it. So what is use B? Use B at the beginning, it is 0 or something else. At the beginning, I don't care. So when I do the backing up, I will copy all the elements. from this position to that position using the green arrow. Okay, but okay, this is backup. When I do the restore, restore is going to copy elements from here to there. So this is going to be restore. So that's the design of the book. Okay, they are using this one. Okay. Good. Any questions? Any questions? If there are no questions, then yes.
So I have a question. Derived class should have base classes constructors, as you told us.
Should call base classes constructors, yes.
Yeah, but in this example it doesn't. Is this a problem or is it okay?
But I didn't show you any code yet. How did you know that the derived class does not call the base classes constructor?
We don't type them in header?
No, we don't.
Okay.
Calling the base classes constructor is part of the implementation. I did not show you the implementation yet. Implementation is here. See? It calls the base classes constructor. Base classes constructor. Calling the base classes constructor is like initialization, okay? And the initialization is part of the implementation. I don't write any initialization code in the header, right? The initialization is not part of the header. It is part of the implementation. Good. Okay. Any other questions? In fact, before we go into the details of the implementation, let's see the example code, driver code. Driver code is here. Okay. Main is calling this test pfrad backup. Okay, let's look at this function. This function says that, okay, give me a capacity. It takes a capacity from the user, from the keyboard, and when I say pfrad backup a capacity, okay, it makes an object of the size, capacity size, and I ask the user to enter that many non-negative numbers, doubles, and I get them one by one. And like I am using a pfrad object, regular pfrad object, I am using this pfrad backup because there is a relationship between them, right? Okay, so I add all of my elements. I don't know how many I added. Okay, I don't know how many I added. I don't know. Maybe capacity of them, maybe before that, but I added many of them. And after this loop ended, okay, after this loop ended, okay, after this loop ended, what I do is I get number used, okay, as a count. I have this many elements in it, okay, and I print them out on the screen. Okay, so I tested it and I printed them out on the screen, and then I call this function backup, a.backup. So I am storing all those numbers to some backup place, whatever I got it. So I am doing this. I am copying all of them to backup. Okay, I did that, and after that, what I am doing is, okay, after I take the backup, I say that I empty the array. What does the empty array do? Remember what empty array does? Does anybody remember the implementation of empty array? Does anybody remember the implementation of empty array.
Make the use the 0.
Exactly, make use 0. So when I do the make use 0, okay, and when I say get number used, it will be 0. So this loop is not going to print anything. But right after that, I just say that, okay, since I lost everything, I will restore now. I will restore everything and I will get my numbers back and I will print them out on the screen. So this is a simple driver code for this class. Okay, now this driver code understood, so you know what we mean by this. Let's go to the implementation and let's see the implementation. First, let's remember the implementation of the base class. Okay, include IOStream. I am just using a declaration, not directive. Okay, and I am including, of course, the pfarray.dh. Okay, my constructor, my user 0 capacity is 50. Okay, my constructor that takes a size, good, no problem. And my copy constructor, I need this because of the pointers involved in it. And my index operator, assignment operator, etc. Everything is like we did before. And nicely, I have this capacity check. And my index operator, where is my index operator? Index operator is checking the range again. And empty array is doing this, use the 0. See, the empty array doesn't empty array doesn't modify any array elements. It just says that now I treat them as junk data. So I will leave them as they are. I don't care what they are. The important thing is that my use is 0 now. Okay, let's go to the implementation of the new class, the derived class, pfarray.d backup. Okay, pfarray.d backup. So this pfarray.d backup is constructor, and the constructor, the no parameter constructor, since it doesn't take parameters, it just calls the base classes no parameter constructor. But it does something here. It says that for B I will get some new space, dynamic space. Okay, so this class will use twice the memory of a typical pfarray.d object. Why? A is going to hold, let's say my capacity is 50. A is going to hold a pointer for 50 double space. B is going to do the same thing. So there will be 100 doubles allocated for this class objects, pfarray.d backup. So it is a more expensive class. Even though at the beginning I never use any of them, I will allocate that kind of space. Okay, so I do that. That's one thing. So as soon as I create my object, okay, remember my base class constructor is creating a space for 50 doubles, and this one is doing another 50 doubles too. If the client gives me a capacity value, I immediately pass that capacity value to my base constructor so that pfarray.d part is handled fine, and then I will do the same thing with the backup space. Okay, so I call my base constructor. For the copy constructor, I call my base constructor too. Okay, see, remember this? What did we say last time? We could do this because there is an is-a relationship. Why? Because this base class constructor expects base class constructor expects a base class object, but I am sending a derived class object, which is fine. There is an is-a relationship between them. By the way, let me go to this slide and let me talk a little bit more about this is-a relationship. Okay. What did we say? There is a relationship between employee and hourly employee, but there is no is a relationship. No is a relationship in that way. So is a relationship is not a two-way relationship. Hourly employee objects, okay, are employee objects, but not all employee objects are hourly employee objects. Okay, so inverse is not true. Okay, so I could do this. There is a relationship between each PF_RAD backup object is also a PF_RAD object. Okay, good. So this is our implementation. What do? I say that, okay, the base class part is initialized fine. Now I am going to initialize, okay, copy construct my part, which is related to B and use B. So what do? I say, I get a need space of capacity. This is my use B. And I am going to copy all of my values up to use B from the old objects, which is this one, .bi. Okay, good. Question, what happens if I do this? Is this okay?
It is okay because we overloaded it.
Yeah, the base class overloaded this index operator. So this will compile, but logically, is this okay? What is this doing? Let me tell you what this is doing. This is exactly the same as what? This is exactly the same as doing this, right? So these two things are the same. Is this okay? Question, is this okay?
No, I guess.
Why not?
Because B parentheses, square parentheses is using inherited class, base class. But we need to store in backup.
Yeah, I should not copy. When I make a new object, okay. When I make a new object, I should not copy between the A part and the B part, okay? When I make a new object, I should copy the backup part to backup part and the regular part to regular part. I should not be copying back and forth between the backup and the restored part. Okay? So this is not okay. Don't do this. Where is my cursor? Don't do this. So the correct implementation is .b. Okay, good. Oh, okay, it looks like we need a break for 10 minutes. Okay, we will be back after 10 minutes.
Hocam merhaba. Hocam bir şey sorabilir miyim isterseniz?
Evet.
Bu sınav dokümanıyla ilgili bir değişiklik yapmaya gerek var mı peki hocam? O şey dedik ya, 5-10 dakika sınav kağıda yazma süresi verelim diye sordum.
Onu sınavda söyleyeceğiz yazdım ya ben. Sınavda söyleyeceğim.
Sınavda tamam yazmayalım yani.
Yazmayalım.
O zaman dokümanı direkt yayınlayayım.
Ha, şimdi gönder, daha geciktirmeyelim.
Tamam.
Yarın sorsunlar. Okay, so let's continue our study of PFRAD backup class. So this is the copy constructor. Copy constructor, first it calls the base class copy constructor. Then it does everything that is related to the backup part of the class. Okay, let's see how the backup works. Backup is very easy. It just says that, okay, the number is used is my backup number used, and I am going to copy everything from from the regular storage place to my backup storage place, and it says that I am going to use the index operator. And I think this would be fine if I had used something like this. Okay, can I do this? Can I an index operator? Where is my index operator? I'm trying to find the index operator position. I think it was somewhere here, somewhere there. Let me copy this. I don't know where it is. Okay. Okay. Do you think this would be fine? BI is AI. Is this okay? Two questions. Does this compile? If it compiles, does it work? Does this compile?
Yes.
It compiles, but I am trying to access the data member A of my base class. Let's go to the header file. In my base class, A is protected. If it was public, then I was in trouble. Okay, it is protected. Since it is protected, we could access it from the derived class because it is protected. So this notation is fine too. Instead of using this index operator, I am using the object, the data member A directly. Okay, look at this one, the restore. Restore is doing something. Restore is doing something smart. It says that all I'm going to do is I will empty this array. Whatever I have, I will ignore them, and I will ignore my elements one by one. Add element BI. Right? Add element BI. So this will work. How about this? Can I do this? Instead of doing that, can I do this? Again, does this compile?
It will compile.
It will compile, okay, but does this work? Does this do the same thing as the code on the left?
I think yes.
Anybody else?
I guess no.
Why not?
Because operation overloading square bracket is using the same protected variable. But we need to restore. We need to assign it.
Yeah, so it is the index operator is using A, right? Not B. Is that, yeah? We need to get from backup space to the regular space. This is what this one is using, the regular space. So this is wrong. This will compile, but it will not work. It will not do whatever we want. Okay, good. So this is wrong. It won't work. And this is okay. Okay, assignment operator. Assignment operator, remember this code from the book slides? The book says that if you are writing the assignment operator, always use the base class as assignment operator as your first thing to do. So I call my base class as assignment operator, and after that, the base class as assignment operator handles everything about use B, capacity, and pointer, double pointer A. Okay, so I need to handle everything about this the new place, backup space, and size of it. Okay, so I say that if my capacity is not the same as the right side capacity, then I know that I need to resize myself. Okay, then I am deleting myself and I will get some new space, and I get the use B value from the other side, and I get all the values of that the other side to my backup space. So I am copying from backup to backup. So in comparison, let's look at the assignment operator of the base class. It is here. It says that, okay, if right side capacity is not the same, it is almost doing the same thing. I get a new space of the right side, but I am modifying A, not B. Okay, this one modifies B, not A. Okay, PFRAD CPP, capacity gets and used get, and I copy all of them from A to A, and I return this. And I am doing almost exactly the same thing. I am copying from B to B. One is copying the regular storage space. The other one is copying the backup space. And the derived class destructor is just deleting whatever I have in the backup space. So this one doesn't call anything about, doesn't talk anything about base classes destructor, because calling of the base class destructor is something done automatically. Good. Any questions? So this one uses 2 times the mechanism of, this one uses the mechanism of dynamic allocation 2 times, one for the regular storage space, the other one for the backup space. So it's a good example to learn about this dynamic memory allocation and the inheritance. It is a good example, but I must agree that this is not a good design, because I am doing things 2 times, right? One for the base class, the other one for the derived class, and I am doing all that. Dynamic memory allocation, deallocation stuff 2 times. Like they look like. I mean, look at this implementation of the assignment operator. It's almost the same thing. This assignment operator, okay, and this assignment operator. Let me try to align them sidewise. How can I align them? Let me. Okay, this is the top line, and let me put this to top line too. One more line. Yeah. See, they are almost the same thing. These 2 things. One of them, of course, is trying to call the base class is assignment operator. But other than that, just checking this and doing this loop, it is almost the same thing. Let me try to do two more stuff, even better alignment, like this, and this one like that. Okay, so it is almost the same thing, only A's and B's are changing. So what is the difference? One of them is, oh, okay, so one of them has extra space in there. Okay, let me put this extra space. So it is almost the same thing. It is almost the same thing. See? So I don't like this kind of copy pasting stuff. Do you have any solutions? Do you have a better design ideas for the implementation of the backup array? Instead of using the dynamic memory, can we use something else here? Can we use something else here? Find me a solution that will avoid any dynamic memory employment in the backup array, PFArray backup.
We can use fixed size arrays.
Fixed size array, but in that case, how am I gonna take a backup of dynamic array?
We can use vectors.
We could use a vector. Yeah, well, I mean, I don't want to use a vector. Yeah, I mean, the idea is good. Somebody said that. I don't know who said that. Somebody is telling me that, why don't we use a vector here? I mean, if you're going to use a vector, okay, if you're going to use a vector, why are we using the dynamic allocation in the, okay, so it's like this one, right? Or B. Okay, if I do that, okay, now I don't have to do the big three because I don't have any pointers in it. So if I have a vector of B, let's try to see. I am not going to change a single line in my interface, and my code, client code, is going to work. This is the good part of the object-oriented programming. You change your implementation the way you want. Your interface will not change, and your clients will not get affected. In fact, your clients will not know that you have changed your implementation. Okay, let me go to the implementation here. So what I do is B, okay, PFArray D, I am calling the constructor of it. And what am I gonna do with this? What was the name of our okay, it was name is B. Okay, it's same as B. So what are we gonna do? B dot resize 0. That's what we do. Okay, good. And since B is a vector now, right? I am using this vector stuff. And I can go on and question if my private part is like this, do I need to write the copy constructor? Do I need to write the copy constructor? Or assignment operator or the destructor?
No, I guess we can create a PFD array D object in private area.
Oh, that's a good idea, but let's come back to your idea later, okay? Let's try to do this vector thing first, okay? I have a vector of doubles, and I ask you a question. Do I have to write the big three in this case? Do I have to write the big three in this case? The answer is no, because I don't have any pointers, and member-wise
We
copy.
don't need to, because a vector can assign to another vector without overloading.
Yeah, member-wise copy with the vector is okay because the vectors know how to assign themselves. We don't have to. Okay, good. So this is a good solution, but I don't like this solution because this is using the vector. Okay, I mean, if I had the vectors, why do I need the PFRAD, right? So the other suggestion was, why don't we use, that was a very good solution actually. Why don't we use a PFRAD object in here? Okay, B. Good. Okay, not vector, but a PFRAD. Can I do that? Can I derive from this PFRAD and can I use it as a data member? It looks weird, so weird. I mean, let me try to draw the diagram. It's like PF array D is my class, and I am deriving a PF array D backup. Also, I am doing this. So PFRAD is both my base class and also there has a relationship. PFRAD backup has a PFRAD. Also PFRAD is a PFRAD. Is this possible? Well, the syntax allows it. Why not? Right? Would this compile? Yeah. Why not? This would compile, no problem. Okay, let's try to implement this. Here I will do what? I will do b dot. Okay, I will do okay, good. This is what I am gonna do. Tell me, what should I do? Tell me, what should I do, right? What should I write here? Okay, I will give you a hint, empty, deliberately. So what should I do? Of course, there will be no use anymore. Somebody tell me something.
We need to give a space for B object.
Yeah, so what should I do that? How should I do that?
You can use copy constructor or directly you can assign a new object to it.
No, the better is this. How about this? I am calling the constructor of my data member, which is B. Okay? What is my B? B is a PFRAD object, right? What is the constructor? What does the constructor do? It takes a capacity and it initializes it, right? This is what I do. I initialize my B with 0. Okay, how about the next one? This one. I just get rid of it. Get capacity. I call my base class's capacity value and do what again? Tell me what I do. I do this. Again, B. What should I write?
Capacity value.
Exactly. Here. Okay. And do I need the copy constructor? Do I need the copy constructor? The answer is no.
No.
Why? Because my data member knows how to copy itself. Okay, I don't need to do that. Okay, so I get rid of the copy constructor. Okay, let's look at this good part. Backup. How do I do the backup?
we use assignment operator.
How can I do that? That's a good idea, but how can you write that in C++? I mean, in English, it sounds very nice, but in C++, how can you construct the same sentence?
A assign B that A could be.
A assigned B dot, what is A? There is no A in B. Oh, you mean that one. B dot A, since it is protected. But if you do that, these two are going to have the same array. They are pointing to the same array. This is going to create problems. That's not good, no. Why don't we use a loop? Okay, first I will do this b.empty array, right? So I emptied B. Then I am going to do this. A for loop is going to do, okay, from 0 to I less than what is used, right? Is there such a thing as used? What is my get number used? Yeah, the get number used. Okay, tell me what should I write here now? Tell me what should I write here? B dot, yes, add element. Exactly. Now what?
AI.
AI or operator I, right? Like this. Okay. Find this one and get rid of this thing. So that's nice, good. Okay. How about restore? How should I write restore? Restore, okay, empty array is there. And add element. Oh, does this work really? There is no USB thing. There is no, instead of USB, what should I write? Instead of USB, what should I write?
B nokta get number used.
Yes, exactly. B dot get number used. Okay. Add element BI. BI is right? So, and I don't need the assignment operator because we already handled it. And I don't need the destructor. Because I don't have any dynamic allocation stuff. So I get rid of this one. Restore is fine. Backup is fine. Constructor is fine. So that they turn out that this PF array, the backup age is very simple and effective class. Yeah, okay, that's good. Okay. How about this? I like to do this. I like to do vector. So I can do many backups as many times as I like. Every time I say backup, okay. Now the current implementation just takes a single backup, but I like to able to do as many backups as I like. So each time I make a backup, I will add a new element to this vector, right? I can do that. So this is an exercise for you. You guys do this yourself. Okay, this is an exercise. So take as many backups as you like. Every time you make a backup, you add a new element at the end of this vector. And every time you make a restore, you remove one element from this vector. Implement this, then later get rid of the vector and do this. Okay, this is even better. And after that, this is much better exercise. Okay. Okay, of course, with this one, you need the size now. You need the int vect size with this one. You understand what I mean here, right? So if you can do this, that means that even though this is about inheritance, okay, this example is an inheritance example. This is a dynamic programming, a dynamic memory allocation example, and it's going to be a very good exercise for the midterm. Do this, and you will understand lots of stuff. Okay, good. Are there any questions? I guess there are no questions. If there are no questions, then I will close. I'm not going to say this. I don't remember what I did. So I will start the new chapter now. New chapter is about polymorphism. I won't be able to cover the whole thing, of course. We need more time on it, but I will make an introduction, and we will talk about what polymorphism is. You understand what inheritance is, right? Inheritance is about is a relationship. The inheritance is about is a relationship, okay? And compiler knows about is-a, and we could use this feature of C++ or object-oriented programming languages to write very, very general code. Remember at the beginning of the chapter what we said? At the beginning of the chapter, okay, we do inheritance for writing generic code or general code. Why? Because I have written code for the employee. Later that code, although by itself employee is not a very useful code, later it became very useful when I write the code for the hourly employee or the salaried employee. Okay, it was very useful. I wrote the code for the PFRAD class. Later it became very useful for my PFRAD backup. Okay, so I reused that code without changing anything. And in fact, that code didn't know anything about inheritance, but it became very useful. And we are gonna use this inheritance feature of the object-oriented programming to write even more general code under the name of polymorphism. And that's going to be our next fundamental of object-oriented programming, polymorphism. The name polymorphism sounds complicated, but it is not actually, and you will see why. And again, with this chapter, I am not going to introduce many new C++ syntax mechanisms. It will be mostly what we know. Okay, chapter 15, and we are down to the final fundamental of the object-oriented programming. And once you start understanding polymorphism, you will say, yeah, that's very useful. And in fact, this polymorphism is as important as composition or abstraction or inheritance. Okay, it is used very, very widely. Okay, so let me, before talking about polymorphism directly, okay, let me give you this hierarchy. Okay, let's say I have a shape class. Okay, I have a shape class. That shape class has 3 functions. Okay, that shape class has 3 functions. One is area, the other one is perimeter, the other one is draw. Okay, shape is like a 2-dimensional shape, like circle, rectangle, polygon, or triangle, doesn't matter. Okay, so later I'm going to use this base class shape to derive new classes. Can anybody tell me how to write the area function of the shape? how would you implement the area function of the shape? What would you return? What is your formula for shape? Or perimeter? Area is alan, perimeter is the çevre in Turkish.
I think it will be different for every child.
Yeah. For the base class, I cannot write it. It's like print check, right? We could not write print check. We could not write print check for the employee class, right? Because it didn't make much sense. We don't know how should I pay an employee, because if it's an hourly employee, the pay is different. If it's a salaried employee, it is different. It's same as that. So for the shape class, I cannot implement area function or the perimeter function or the draw function. I don't know how to draw a shape, but I can write such a thing, right? Can I write a function like this? A function that takes shape pointers and it says that give me 10 shapes, whatever it is a rectangle or circle or whatever it is, okay? I will return you the total area of this shape, of these shapes. Can I write such a function? The answer is of course, why not? What I do is I take this vector and I run a loop from 0 to the size of the vector, and for each element I call the area function, okay, and I add them up and I return this one. Okay, so here our argument is this: even though you don't know what kind of shapes these are, I can write this generic code. I can write this generic code, okay, and this code will be useful for any type of shape. I don't care if I derive new shapes like triangle or rectangle or ellipse or polygon, doesn't matter. This code doesn't know anything about them, but it still works for any kind of shape. So it's a generic code. I am using inheritance to write more generic code. This area here, this function will be different function for each iteration of this loop, right? This area depends on the object that is pointing to, okay? Whatever this vi points to is a pointer. If it's a circle, then the area of the circle will be called. It's a rectangle, area of the rectangle will be called. It's like dynamic, right? So during the runtime, dynamically, my area function changes. So this is called polymorphism. Poly means many, morph means shape, many shapes. Okay, so during the runtime, my shape changes or my faces changes. Many. Maybe I shouldn't say shape because you are going to get confused. Poly means many, morph means face, many faces. Okay, so this area has many faces, and the face depends on this vi. That's where polymorphism comes from. Okay, I think I will cut this short for today, 10 minutes early, because I have a meeting. Tomorrow we will continue from this point on, okay? So let's stop today, and tomorrow we will continue. I'll see you tomorrow morning.
Thanks, sir.
Thank you.